Hello everyone, welcome to the Third Benches YouTube channel. Today we will see CSIR LifeSciences December 2016 Part A solutions from questions 1 to 10. Question 1. The random errors associated with the measurement of P and Q are 10% and 2% respectively. What is the percentage random error in P by Q? Here, random error can be found by standard deviation. However, since the values are already given, that is for P it is 10% and Q it is 2%. So to find the random error for P by Q, there is a simple formula. If P and Q are correlated, then random error in P by Q is going to be the sum of the individual error percentages, that is 12%. However, in this question, there is no hint of whether they are correlated. So these can be considered as independent variables. So when P and Q are independent, then we have to find the percentage random error in P by Q by using Rss method, which is the root sum of squares. Root sum of squares. So here what happens is we take the root of the sum, the squares of the individual percentages, that is 10% and 2%, which is 10% is 0.1 squares of these values. So 0.1 square plus 0.02 square, which is 0.01 plus 0.0004, which is root 0.0104. Now the root of this value has to be found, 0104. So 1 ones are 0, and bringing this value down 2. Now this value will not go, so it has to be 0, again 4, which gives us 201. And further on 202, which is 9 times 2029 times 9 is 18261. So this is the square root of this value, that is 0.1019. So in terms of percentage, we have to find a value in percentage, we have to multiply it into 100. So this 10.19, which is equivalent to 10.2%. So option 4 is the correct option. Moving on to the next question. In how many distinguishable ways can the letters of the word chance be arranged? Chance is a 6-letter word. 6 letters. So it can be arranged in 6 factorial ways. However, we have to note that C is being repeated twice. So we have to remove the instances where C is being interchangeably used. That is, say this is C1 and this is C2. Now this is similar to this. However, each of these will be counted in this when we calculate it by this way. So we have to remove. So how do we remove this? We have to divide it by the repeating values. So this is going to be 6 into 5 into 4 into 3 into 2 by 2 into 1, which is 360. So option 3 is the correct option. Moving on to the next question. Find out the missing pattern. Here we have to find out the missing pattern. Here it is given as plus, this is division, this is subtraction. So the other thing has to be multiplication. First one it is given in the top, this is in the bottom, and this is to the left. So the next one should be in the right. So we can eliminate second and fourth options. So in these two cases the multiplication symbol is in the right. Next, we have to see the order in which it is being done. 2, 5 plus is 7. 8, 3 divided is 6, and 8 divided by 6 is 3. Now 9 minus 7 is going to be 2. So 9, 7 minus is going this way. Similarly, 2, 5 plus is 7. So it is going this way. And in this case, it can be going this way. 8 divided by 6 is going to be 3. So all of these values are moving in the clockwise direction, right? So in this case also we have to choose which is moving in the clockwise direction. Here 7 2 in times is 14, that is 7 into 2 is 14. Whereas in this case it is going in this way. So option 1 is the correct option. Moving on to the next. Seeds when soaked in water gain about 20% by weight and 10% by volume. By what factor does the density increase? Here, mass and weight can be interchangeably used. What is density? Density is mass by volume. So let us first let initial density be d dou I, that is rho I plus is mi by vi. Now the final density is going to change. So how much is it changing? Let's say that initially everything is 100%, right? Then the final value, that is final mf, is going to be 120%. That is 1.2 of mi. 120% of mi. So it is 1.2 of mi. And vf is changing by 10%. So it is 110% of vi. That is 110 by 100. Right? In terms of decimals. So this is going to be 1.1 times vi. So dou f is going to be mf by vf, which is 1.2 mi by 1.1 bi, which is 1.092i. So the factor by which the density increases is 1.09. So option 4 is the correct option. Moving on to the next question. Question 5. Retarding frictional force F on a moving ball is proportional to its velocity. Two identical balls roll down identical slopes from different heights. Compare the retarding forces and the velocities of the balls at the bases of the slope. Okay, so here we have to find the relationship between velocity and frictional force, retarding frictional force between the two situations. Here the ball is at a higher position at a higher height than this ball. Okay, so let us first calculate the energy that the ball possesses at the slope. In both situations, at the slope, the total energy is going to be a sum of kinetic energy and potential energy. And let this kinetic velocity be Vs, that is V slope. Now, at the base, this total energy is converted to kinetic energy, where Vb is the velocity at the base. So, this total energy is going to be converted to this value at the base. So, when we equate these values, we find that h is directly proportional to Vb, right? So, the higher the height, the higher is the velocity at the base. So, here these two balls are differing only in the height. So, Va is going to be greater than Vb. So, this is the conclusion from this inference. So, we can easily eliminate options 2 and 3. Now, among 1 and 4, this is now the trickiest part, because frictional force, as we know, is the force that is going to oppose, that is, it is going to retard the motion further. However, there are two different cases. One is slipping motion and the other is rolling motion. Slipping and rolling motion. In the slipping motion, the direction of motion is going to be this, and the frictional force will be opposing, that is in the opposite direction. However, in rolling motion, what happens is at the point of contact, when we zoom into this point, at the point of contact, the ball is going to move backwards, and hence the apparent frictional force is forwards. So the actual for a ball that is moving on down the slope. So here we see that the friction force is along the direction of the motion of the ball. So here F is actually proportional to V. This can also be proven as from acceleration. F is equal to ma, and a is V minus u by t. So here we see that F is directly proportional to a and a is directly proportional to V. This gives F is directly proportional to V. Okay, so these cases prove that the frictional force will also follow the same pattern as that of velocity. That is, Fa is going to be greater than Fb. Therefore, option 1 is the right option. Moving on to the next question. Two cockroaches of the same species have the same thickness but different lengths and widths. Their ability to survive in oxygen deficient environments will be compromised under what conditions? Compromised means retarded or affected. So under what of these conditions will their ability to survive be retarded, that is be affected? So in condition 1, where their thickness increases and the rest of the size remains the same, that is T is increasing, their thickness remains unchanged but their length increases, L changes, width, their thickness remains unchanged but their width decreases, their thickness decreases but the rest of the size remains unchanged. So under which of these conditions do you think that their ability to survive is going to be compromised? Now this is a very biological question and I wonder why this is in general aptitude section. So by approaching it in a logical manner, I'll first say that cockroaches are arthropods. They belong to the phylum called arthropods. And hence, the respiratory system of arthropods occurs via their general body surface. So, increasing the thickness will impede its ability to respire and thus survive in oxygen deficient environments. So, my guess would be option 1. Now, to analyze this question in a little deeper manner, let us see the diagram of a cockroach, the respiratory system of a cockroach. Now, assume that this is the cockroach. So, cockroach has spiracles at the lateral sides of the body. These are muscular valves that enable respiration through the body. So here these spiracles are present on the lateral sides. So if thickness is going to be increased, as I said, the body surface is going, the air molecules will be, it will be difficult for the air molecules to penetrate through the body. So this could be a potential candidate. Their thickness remains unchanged but their length increases. If length increases, then there will be more number of spiracles and thus it will be an advantage for them to survive. That is, their survival will be increased. So it will not be compromised but increased. So this will enhance its survival. When the width decreases. Now we see that width does not have a direct role in its respiration. So no change when the width decreases or increases. Now their thickness decreases but the rest of their size remains unchanged. That is, thickness decreases. So when thickness decreases, again as I have mentioned, there will be enhanced effect because lesser thickness enables penetration of air. So option 1 is the correct option. Moving on to the next question. 7th. The bar chart shows number of seats won by 4 political parties in a state legislative assembly. 50, 35, 20 and 35. Which of the following pie charts correctly depicts this information? Now, this is a very simple question. First, let us total the number of seats won. So 50 plus 35 plus 20 plus 35, which amounts to 140 seats. Let's name these parties as A, B, C and D. Party A has 150 out of 140 seats. Party B has 135 out of 140 seats. Party C has 120 out of 140 seats. And Party D has 135 out of 140 seats. Now as we see, 35 has been repeated twice. Now also it is clear that none of the parties have got a majority. That is at least half. None of the parties have got at least half. So it is safe that we eliminate this option. We can eliminate this option. Also this option can be eliminated as it shows equal distribution for all the parties. Now among these two options, only this option has 2 equal halves in one quarter, in one hemisphere. Whereas here all the 4 are different. However, we see that B and D have 1 equal number of seats. So this can also be safely eliminated. Option 2 is the correct option. Now to just verify our hypothesis, let us see how much this could be. Now 35 and 35 together form 70, which is 1/2 of the 140 seats. And similarly 50 and 20 form 70, which is the other half of 140. So this could be 35 and this could be 35, and among 50 and 20 this would be 50 and this would be 20. So this is the apt representation of the number of seats won in the state legislative assembly in the pie chart diagram. So option 2 is the correct option. Moving on to the next question. Intravenous fluid has to be administered to a child of 12 kg with dehydration at a dose of 20 mg of fluid per kg of body weight in 1 hour. What should be the drip rate of IV fluid? Now the given data is that the child is 12 kgs. Dose is 20 mg per kg of body weight in 1 hour, right? Dose is 20 mg per kg in 1 hour. So what should be the drip rate is a question. Also it is given that 20 drops corresponds to 1 mg. For this child, specific dose is going to be 20 mg into 12. That is, for each kg 20 mg has to be administered. Child weighs 12 kg, so this much amount of drug has to be administered to the child in 1 hour's time. right? Now convert this mg into drops. To convert it, 20 drops corresponds to 1 mg. Then 240 mg will be corresponding to x drops. So x is going to be 240 into 20 by 1, which is 4800 drops per hour. To convert hour into minutes, because it is asked in drops per minute. So to convert hours into minute, let us divide the whole value by 60. Drops by 60 minutes, which is going to be 80. So 80 drops per minute is the correct option. Option 2 is the correct option. A hall with a high roof is supported by an array of identical columns, such that to a person lying on the floor and looking at the ceiling, the columns appear parallel to each other. Which of the following designs conform to this? So here there is a floor and there is a high-rise roof. Now a person is staying here and is observing the roof. Now, under which of these conformations would the columns appear parallel to each other for the person lying on the floor? So in this case, to solve this problem, we need to know the concept of perspective diagrams. So here, remember in childhood, for drawing doors, we draw them. For an open door, we draw it like this. So this is going to be how we are drawing. That is because this kind of drawing gives a depth to a 2D image. That is, it gives a 3D effect to a 2D image. So this is the basics for architectural drawings. So say for a person standing at the entrance of a hallway, how he perceives the hall is going to be this way. Even though the walls and the roof and the floor are all parallel and the walls are parallel to each other. However, for a person standing in the entrance of the hallway, he would see the entire hallway in this format. So that is because of the concept called perspective drawing. So everything converges to one point. At infinity, all of these would, if this hallways was of infinite distance, then all of these would appear like this, projected inwards. Okay, so this is called perspective drawings. So for this case, for parallel columns, we see that when a person stays at the floor, is lying on the floor and sees the ceiling, it would appear converged. So this would not appear parallel. Similar to this case, this would also appear converged. And in this case, it is already converging in nature. So this would again converge more. So these columns also would not appear parallel. In this case, we see that the columns are placed this way. So even though by rules of perspective drawing, these would tend to converge. However, for the person lying on the floor, these would appear parallel because from this position they have moved to this position. They appear to move to this position. So these are the rules that would appear parallel for the person lying on the floor. So option 1 is the correct option. Moving on to the next question. Which of the following graphs correctly shows the speed and the corresponding distance covered by an object moving along a straight line? Here, distance is represented in blue line and speed in dotted green lines. Okay, now which of the following graphs correctly shows the speed and the corresponding distance covered by an object moving along a straight line? Okay, to find the answer, we need to have a basic idea of how derivative graphs would appear. So when if x is distance, then speed is the derivative of x. That is, it is dx by dt is the speed. Okay, so this first analyzing graph 1, the graph appears this way, and this curve is similar to e power x curve. If this is the distance curve, that is, if the distance curve is equivalent to e power x, then speed, that is differentiation of this, is also going to be e power x. So the speed curve should have also followed this format. However, it is following a different curve. So option 1 is not true. Now option 2. Here it is seen that distance is linear. The graph here is a straight line, right? So this is a linear graph. That is y is equal to x or some kx. And hence, say differentiation, that is speed, would be constant because dx by dt is going to be k, right? So this in this case, if this is the distance, then the speed should have been something similar to this. However, this is not the case. So this is also wrong. Now this is in this case, we see that distance is sigmoidal in shape and the speed follows a curve of this pattern. So this is actually the correct answer, and I'll come to this as to why this is correct in a little while later. And option 4, as we have already seen, when speed is going to be constant, the distance is going to be linear. However, we see that this is also curved. So option 4 is wrong. Now why is option 3 correct? Remember, in our 12th, for volumetric analysis questions, we followed the pH indicator to find the exact volume at which a reaction occurs, right? So those reactions follow a sigmoidal curve. That is, they are constantly at one base, at one value, and then suddenly rise to a different value. Say this value is at 3. When we differentiate this value, we get a graph like this at the exact third point. So these graphs are for titration curves. So this is how we used to find the values, and now we see that this distance is sigmoidal and the speed, which is derivative of distance, has followed a curve which is similar to this. So option 3 is the correct option. Hope you have understood the answers, the solutions. Thank you for watching. Please tune in for more videos.